Welcome to Ask and Learn.
So to start these mixing problems, you have to actually write the differential equation. Before we do that, it might be helpful to clarify what the question would mean by percent. As you can see, they're written as decimals. So basically what percent would be is the proportion. So P is going to be the proportion of CO2 or carbon dioxide among the whole 180 volume of the room. So we can call that C over 180, the volume of the room. So if that's the case, then that would mean that C is equal to 180p, and therefore C prime, or rather the derivative of C respect to T is equal to 180 times, sorry, that's a 180 times the derivative of P with respect to T, sorry, dP by dt. And now we can actually start writing the equation. First, we'll write it in terms of C just to make things clear. So basically the amount of the rate of carbon dioxide entering in the room is going to be equal to the rate of in, which is going to be that it's 2 meters cubed coming per minute, and 0.5 times that is the actual amount of CO2 coming. So 0.05 times 2 is going to be the rate in, and then we're going to have minus the rate out. So the rate out is going to be, well, once again, it's a percent, but specifically it's the percent of, since it's all coming uniformly out of the room, it's going to be the percent that's already in there, which is P, and then times 2 again. It says the same rate coming out in terms of volume. And now as we said, this is just equal to 180 dP by dt. So to be clear, what we have is 180 dP by dt is equal to 0.05 or 0.1 minus 2p. And from here, it could be helpful to make sure that there's not like a coefficient on the p by dividing both sides by 2, or even rather by -2. It's up to you. You don't necessarily have to do that, but what we would get then is negative 90 dP by dt is equal to P minus 0.05. And now notice this is a separable equation. We have, since everything's in terms of P, what we'd have to do is divide both sides by P minus 0.05 and by negative 90 to get P minus 0.0, sorry, no, I said we're dividing by that, so 1 over P minus 0.05, and then dP by dt is equal to negative 1 over 90. And then what we can do is sort of multiply both sides by dt, and then integrate both sides. Now integrating that left side with respect to dP, you're going to get negative ln absolute value P minus 0.05. And on the right side here, that would, of course, just be negative 1 over 90t. And then you can put an arbitrary constant, which I'm just going to call C. Don't let that confuse you with this one. That was capital C for amount of carbon dioxide here. This is just a lowercase c arbitrary constant. And you could put it on either side since you're integrating either way. It doesn't matter. But now what we're going to do is we're going to isolate P. So first of all, we can so that there was a mistake here. That should not be, there should be no negative sign. There's no negative on the P. We made sure of that earlier, so you can ignore that part. But yeah, now what we can do is, of course, to isolate P, we can take e to the power of each side, like this. And basically what that gives us is absolute value p minus 0.05 is equal to e to the c minus 1 over 90 t. And then we can do this trick that we do is so that when you getting rid of the absolute value sign, you'd have to put plus or minus on the other side. What we're going to do is we're going to change this part using we're going to rewrite this part using exponent rules, and we have e to the c and then e to the negative 1 over 90t, or t over 90. And basically this part, we're just going to treat it as a whole other one constant of its own, which you can just call k. And we get p minus 0.05 is equal to k e to the negative t minus 90. And once we get to this point, we can use our initial value that we're given, which is that p of 0 is equal to 0.15, because that's what the percent was initially at t equals 0. So subbing that in, we get p, or 0.15 minus 0.05 is equal to k times e to the negative 0 over 90. That's just e to the 0, which is just 1. Get rid of that. And we get that k is equal to 0.1. So that means what we had was p minus 0.05 is equal to 0.1 k, sorry, no, 0.1 is k, e to the negative t over 90. And finally, we have p equals 0.1 e to the negative t slash 90 plus 0.05. And we can rearrange this however we want. Let's choose to do some factoring, and we get that p, we weren't writing of t throughout, but technically you can do that. And p of t is going to be equal to, we could factor out a 0.05, or 1 out of 20. And then inside we can, the order doesn't matter, we can take this term first, and we get, well, if you factor 1 out of 20 from 0.05, that's going to be 1. And then we're going to have, when you factor out 1 over 20 from 0.1, you're going to have 2. So 2 negative t to the, negative t, 2e to the negative t over 90. That's our final answer for what the function is. And then it also asks what happens in the long run. So you're just going to take the limit as p over t, as t approaches infinity of this 1 over 20 1 plus t to this. What we can do is we can take out, first of all, we can easily take out this constant for the limit, and then when we take this, we can also rearrange it such that basically we have, since this is just a constant as well, and this is a constant, what we basically just have is 1 over 20 1 plus 2 times, and now we can take the limit as t approaches infinity of e to the negative t over 90. And as you should know from limits, since there's a negative sign here, so basically the coefficient on t is negative 1 over 90, and it's negative, then as t approaches infinity, this whole thing is going to approach 0. So basically that term will be gone in terms of that limit, and we are left with 1 over 20, or 0.05. So that's the answer to the second part. That's what happens in the long run. The percent approaches 0.05.